In this lesson, we're going to look at exponential notation and order of operations, and that you need to be able to understand both of those. So when we have a 4 written beside itself 3 times, 4 times 4 times 4, we can write this in exponential notation. So this can be written as 4 cubed. Because 4 cubed means 4 times 4 times 4. When we have an exponent, this just tells me how many times I multiply the base by itself. Okay, so what would x times x times x be? Good. Be x cubed. And similarly, how about 4x times 4x times 4x? 4x cubed. Right? Wrong. The way it's written here is not correct, right? Because the way we have it written here, what does this mean? All this means is 4 times x times x times x. What's being cubed the way I've written it here? Only the x. And I need the 4 cubed as well. So you could say 4 cubed x cubed. That'd look a little weird. Let's just use our parentheses. So we'll have 4x in parentheses quantity cubed. And again, what does this mean? What's the base? 4x. So this means 4x times 4x times 4x. So we don't want to get confused when we have negatives in here. So negative 3 squared, we're squaring a negative 3. So this is the same thing as saying negative 3 times negative 3, which is 9. So negative 3 squared is 9. But when we have it written this way on part B, 3 squared with a negative there, this implies this. Negative 3 squared. So this is going to be 3 squared is 9, so we're going to have a negative 9. So make sure you see the difference between A and B. How about negative 2 cubed? So negative 2 cubed, again, is negative 2 times negative 2 times another negative 2. So negative 2 times negative 2 is a positive 4. And then we still have a negative 2. So this is going to give me a negative 8. Pause the video here. See if you can do this next one on your own. All right, welcome back. So negative 5 to the 4th. Again, what does this mean? This means negative 5 times negative 5 times negative 5, and then one more times negative 5. So we have negative 5 times negative 5 is positive 25. Well, first, before we even do that, if we have an even exponent here, we know that the final answer is going to be what? Positive, right? Because when we multiply an even number of negatives together, we know the result is always a positive. A negative times a negative is a positive. So we don't really have to even worry about the sign here. We know our answer is going to be positive. So now we're just kind of worried about 5 to the 4th. Similarly, in part C, when we have a negative to an odd exponent, we know the result is going to be negative. That's another way that when you get pretty good at these, you don't have to actually do what I did right here. We can just say 2 cubed is 8, and I know the answer is negative. So 5 to the 4th is what? 625. So it's going to be a positive 625. I want to erase that. So when a negative number is raised to an even exponent, the result's always positive. When a negative number is raised to an odd exponent, the result is always negative. Okay, so very similar here. 4x cubed, we want to simplify that. So when we have this is really the same thing as 4x times 4x. So 4 times 4 is 16, and then x times x is x squared. Now in practice, I don't really have to do it like that, right? I can just square the 4 to get 16, and square the x to get x squared. So how about on this one? So we have a negative 4x squared. So what do we know from the last lesson, from the last example, about squaring negatives? We know the result's going to be positive. This is negative 4x times negative 4x, which is a positive. So I'm squaring negative 4, which is 16, and then we have x squared. where do the mistakes come? Students will forget to square the 4, and they'll just say 4x squared, so make sure you don't do that. How about 3x quantity cubed? So here we're going to say 3 cubed is 27, and then x cubed is just x cubed. How about this last one? See if you can do this one on your own. So pause the video here. All right, welcome back. So we have negative 3x quantity cubed. So negative 3 cubed is going to be negative 27, and then x cubed. So order of operations. So we talked about this in class quite a bit. So we have a specific order we need to go in, and that is the parentheses or grouping symbols, and then exponents, multiplication, division, left to right, addition, subtraction. And we talked about the PEMDAS, the Please Excuse My Dear Aunt Sally, to help us remember that. We talked about the need for an order of operations too, so I won't go into that again here. So let's evaluate this. So what's going to come first in A? So we're going to do multiplication. So we're going to do 4 minus 3 times 6, which is 18. And then do 4 minus 18, which is a negative 14. How about 4 minus 3 times 6? So here, what do I do first? I do what's in parentheses. So the parentheses force me to do the subtraction first. So 4 minus 3 is 1. So we have 1 times 6 is 6. Now 4 minus 3 times 6 squared. So what do I need to do first here? The parentheses, so 4 minus 3 is 1, times, I'll do this in 2 different steps. We could have gone ahead and squared that out. Now I do the exponents here. 6 squared is 36. So I have 1 times 36 is 36. And this last one on here, 5 minus 3 times 2 cubed. So again, we have 5 minus, do I do the 3 times 2 first? No. I do the 2 cubed first. So do this guy here first. So minus 3 times 8. Now, it's very similar to part A. We do the multiplication first here. So I'll have 5 minus 24, which is a negative 19. So pause the video here and see if you can do example 5. Welcome back. So let's do these. So 5 minus 2 times 3, we're going to have 5 minus 6 minus 8. And here I usually just go left to right here. So 5 minus 6, we have negative 1 minus 8, negative 9. Okay, part B. If you haven't paused the video yet, pause it. Try to do a couple of these on your own. So 4 plus 5, we'll do what's in parentheses first. So we'll have 9. Don't forget the squared. Minus 2 plus. Now I don't want to mess you up here, but we could go ahead and do this multiplication. It's sort of far enough away from this, but I won't, just so you don't get confused. But once you get pretty proficient at these, you can kind of break the rules. You just have to know when you can break them and that they're algebraically sound. So here we have 9 squared. I'll have 81 minus 2 plus 3 times 4. Again, we could have gone ahead and done that, but I'll wait. So that's nothing there. Let me move over here. So I'm going to have 8 minus 2 plus 12. And here we can kind of go in any order, but I'll go ahead and just go left to right. So 8 minus 2, 6 plus 12, and 6 plus 12 is 18. And you do not need to show every one of these steps I've shown. You probably need to have at least one intermediate step in here. Okay, the last one here, part C. Very tempting maybe to multiply the 5 and 3 together first. Don't do that. Fight that temptation. So we are going to do 5 times 3 squared, which is 9. Then 5 times 9 is 45. You'll get better at these order operations when you do a handful of these problems. Okay, one more. Again, pause the video here. See if you can do these. All right, welcome back. I know you paused it. So 4 plus 18 times 3, I am going to divide first. So 4 plus 18 divided by 3, 6. So 4 plus 6 is 10. How about 8 plus 6 over 1 minus 8? Now, when it's written this way, we haven't talked about this yet. I don't think we mentioned it in class. There's an implied parentheses here. So, all right, when we have this big fraction bar, it's implied that we do this, and then, so we do the numerator and then do the denominator. So 8 plus 6 is 14. Then 1 minus 8 is a negative 7. And then divide. Okay, how about part C? What are we going to do first? We're going to do this division first. So we're going to have 8 plus 6 divided by 1 is just 6 minus 8. And then we can just go, it's probably easiest to go ahead and do 8 minus 8 first, which is 0 plus 6. So we just get a 6. Last one on here, part D, 8 plus 6 divided by 1 minus 8. Does this look familiar? It's exactly the same as B. Why did I put this? Often, once we start doing a lot of algebra, we begin to eschew, we shun this division symbol. It just can kind of lead to some ambiguities, and you will see that in a minute. So often students will rewrite it like that, but I won't. I'll just leave it this way. 8 plus 6 is 14. Divided by 1 minus 8, which is negative 7, and we still get negative 2. Again, the same as we got in part B. Okay, last one for order of operations. Again, pause the video here, see if you can do these. Welcome back. I know you paused it. Again, we are implying to do this first in the top, and then in the denominator to do that. So 4 plus 2 times 3 is going to be 4 plus, and let's do this in our head. So we know we're going to do 2 times 3 first, so that's 6. 6 plus 4 is 10. This one we may not be able to do in our head quite as easily. What are we going to do first here on the bottom? Good, the square. So 3 squared is 9. I better write this out. 4 minus 2 times 9. Doing stuff in your head's overrated in some ways. Okay, so I'll have a 10 on the top still, and the bottom. 2 times 9 is 18. So I have 4 minus 18. Again, you could have skipped this step, but we'll write it so you can have some neat notes. And 4 minus 18 is a negative 14. And then we can reduce this fraction. So 2 goes into 10 5 times, and 2 goes into 14 7 times. And we'll just pop that negative up here. Usually we have the negative sign out to the side or on the top, not the bottom, but it doesn't really matter. Okay, what are these symbols here? We'll talk a lot more about this later in the course. These are absolute value symbols. So the absolute value of a number, for instance, the absolute value of a negative 3 is 3. Okay, you can think about it as just measuring distance. The absolute value of 3 is a positive 3. So the absolute value, the range of absolute values, all positive numbers, or not negative numbers. So what do we have here? 6 minus 2 times 3 squared. So again, we still obey the order of operations. These absolute value bars, or you can think of those as grouping symbols. So let's do what's in those first, although there's nothing else outside of that, so not that big a deal. So I'm going to do 6 minus 2 times 3, 2 times 3 cubed, 3 squared, which is going to be 2 times 9. And we just carry those absolute value symbols over. Again, order operations, we do the 2 times 9 next. So absolute value of 6 minus 18. So this is going to be the absolute value of a negative 12. And the absolute value of negative 12 is a positive 12. The last one, we have square root. Again, it sort of serves as a grouping symbol. We do everything in here underneath the square root. So 4 minus 2, the square root of, and this is going to be times. And again, we obey order of operations here. 10 plus 2 cubed, so 2 cubed is 8. So I'm going to have 10 plus 8, and then negative 1 times 2. is minus 2. So 4 minus 2 on the square root of, so 10 plus 8 is 18, minus 2 is 16. It's going to come out nice, right? I can evaluate the square root of 16. So 4 minus 2 and square root of 16 is 4. Again, order operations, 2 times 4 is 8. Let me move up here. So I'm going to have 4 minus 8, which is a negative 4. So evaluating when given a variable. We did a few of these just to make sure we maybe formalize a little bit more and give you a couple of extra examples to see. So evaluate with the variable. Here we have 8 minus 7t, and I'm asking you to plug in a t equals negative 2. So we're going to take that negative 2 and plop it right in for t, or I guess substitute would be a better word than plop, right? So I'm going to have 8 minus 7 times negative 2. And we still obey the order of operations here. So negative 7 times negative 2 is a positive 14. And then 8 plus 14 is 22. Okay, see if you can do these next two. Make sure you get them. All right, so again, we're going to take this negative 3 and substitute it in for the t. So 5 plus 3 times negative 3 squared. We have to make sure we put whatever we're putting in here in the parentheses. So 5 plus, and again, if order operations, negative 3 squared is 9, and then 9 times 3 is 27. And 5 plus 27 is 32. And finally, the last one, I'm going to take this negative 1 and plug it everywhere I see an A. So 4 times negative 1 minus 3 times negative 1 squared divided by 2 times negative 1 plus negative 1. So it looks tough. If you do the operations, it's just arithmetic, right? So let me put parentheses around that. So 4 times negative 1 is negative 4. Order operations say negative 1 squared is 1, and 3 times 1 is 3. So we still have the minus 3, or you could say negative 3 times 1 and keep the negative 3. On the bottom, we have 2 times negative 1 is negative 2 minus 1. Then use to the top and then to the bottom. So negative 4 minus 3 is a negative 7 on the edge here, over negative 2 minus 1 is a negative 3. Remember, plus a negative, plus a negative. And negative 7 over negative 3, we'll rewrite that as, and I'm sorry I ran out of room here, a positive 7/3. So how do we evaluate these on the TI 83 or 84? So fortunately, the TI knows the order of operations. The smart calculator that it is. So there are a couple ways you can do this. With part A, you can just say 8 minus 7, and then you can put parentheses and then plug the negative 2 in. And we get 22, exactly the same thing. Let me show you a quick way to do these. I'll do B another way. When you have a lot of letters, particularly a lot of different letters, we don't have those in this case, but let me show you another way you can do this by actually just plugging the variable in. So what we first do, t equals negative 3. So I'm going to store negative 3 into the variable t. So I'm just going to type negative 3 in this little store command right above the on. And alpha, and here are my letters. You can kind of see them in green on this calculator. And where is my t? Right there. And then press enter. And that tells me that t is going to be negative 3. If you doubt that, you can press alpha t and hit enter, and it's going to be negative 3. And so now I can press 5 plus 3 t squared. And I get 32. Same thing. Okay, this is really nice if you have a lot of these being squared and cubed and maybe even some fractions. It makes order of operations, you don't have to put in any parentheses. It looks a little nicer. That is certainly up to you which way you do it though. I'll let you try it on part C on your own.